everybody, Ms. Marsh here. So we're going to look at the Opt1 Day 11A Study Guide quiz. So remember, for Day 11B you have to do a Study Guide quiz corrections. So this should help you with that. You can go through and find the ones that you missed after you took the test. So ideally you have already taken this test. This is just to help you understand why you got them wrong and to help you do the corrections. After that, it should help prepare you for the Day 12A Mastery Test. So let's get started. So to begin with, it says, what is the simplified form of the expression the square root of negative 64? So when you are square rooting a negative number, we are talking about imaginary numbers. And the most important imaginary number is the imaginary unit I. I is the square root of negative 1. So we can basically pull out that negative from the square root of negative 64, and it would look like this. We take the square root of negative 64 and write it as the square root of negative 1 times the square root of 64. The square root of negative 1 is I, so that turns into I. And the square root of 64 is 8, so these are multiplying, but we put the 8 in front of the I, and there is our answer, 8I. All right, let's look at number 2. Number 2, analyze this graph and determine which function represents the graph. Now, for whatever reason, this printed as a PDF very large, so there's 3 on one page and 4 on the other. And when I look at all my options, I can see that they are in factored form. Factored form is you have the function is sum a times x minus root 1 or r1 times x minus r2 or root 2. And this is the factored form of a quadratic function. We're also going to see a lot with the standard form and the vertex form throughout this test. So with this form, R1 and R2 represent the roots. And if they are real numbers, they are the x-intercepts of the graph. So we can see that there are, in fact, 2 x-intercepts to this graph. There is one right here at negative 2, 0, and the other one right here at positive 1, 0. So that essentially informs us what is R1 and R2, and it doesn't matter which one you label as R1 versus R2. I can call this R1 and this one R2. So that essentially, if we plug that in, we don't know what A is, but it's x minus, could be positive 1, and x minus negative 2, which turns into x plus 2. Now the A determines 2 things. It determines the concavity, the direction that it opens. So if it's positive, it opens up or down, and it also determines this like steepness and the stretch of the graph, either stretching down or up. In this case, I do recognize that it is opening down. So that means that A has to be less than 0. It has to be negative. So I'm looking for an x minus 1 and an x plus 2 in whichever order. I see there's an x minus 1 and an x plus 2 in this option, but this is there's no negative, there's a positive in front, which means this would open up, so that is not the answer. This one doesn't have the right roots, and this is our answer because it has both the correct roots and it has a negative sign in front, which would imply that it opens down. Keep in mind that you can pause it at any time if you need to go back and catch any of that. Okay. Number 3, which is a function equivalent to f of n is equal to n plus 2 quantities squared plus n squared minus 4. So we are given all these different functions in different forms, and basically we need to identify if they're equivalent to each other. And the easiest way to do that is to FOIL, multiply, expand binomials, do all the distribution, combine like terms to the point where they're simplified, then we can compare them. So this first one is what we're trying to identify is equivalent to something else. We're going to have to take this n plus 2 quantity squared. We're going to have to FOIL that or distribute that or however you're taught to call that. You can do n plus 2 times itself. That's what squaring means. You might know the formula a plus b squared equals a squared plus 2ab plus b squared. You could use that formula. I'm just going to go ahead and FOIL, so to speak, or just double distribution. N times n is n squared plus 2n. And then I'm going to do the 2. There's another 2n and a 4. So this part right here is equivalent to n squared plus 4n plus 4. Now if I add that n squared plus 4n plus 4, I add the other parts, n squared and then a minus 4. Let's do our like terms. N squared plus n squared is 2n squared. And then we have a 4n. And then our constant terms actually cancel out because they're the same but opposite. So this is what we're looking for, n squared plus 4n. That would eliminate this one because that one is already simplified and that doesn't work. So we can eliminate that one. The top one, n plus 3 times n plus 1 minus n times n plus 1. We can multiply these together and then distribute this negative n over here. Okay, and then combine like terms. The n squareds are going to cancel, and we get 4n minus 1n is 3n plus 3. That didn't work. That's not going to give us the same thing, so this is not an answer. And so you go along in this way, and you are going to find that the last one, which you can see is the answer, n times 2n is 2n squared, just by distribution. N times 4 is 4n. See how they are equivalent to each other? That's what we were looking for. Okay, number 4. Determine the product of 4 plus 3i times 4 minus 3i. You could just multiply this out. Okay, 4 times 4, 4 times negative 3i, 3i times 4. So basically just do the multiplication the long way. There is a quicker way, but I'll show you this way first. So 4 times 4 is 16. 4 times negative 3i is negative 12i. 3i times 4 is positive 12i. And 3i times negative 3i is negative 9i squared. The negative 12i and the positive 12i are going to cancel. And then you have to remember what I squared is. If I is the square root of negative 1, I squared is equal to negative 1. So I squared is going to become negative 1. So that's going to give us 16 plus 9. And that's how we get our answer of 25. So I said there was a shortcut. If you recognize this as a identity, specifically difference of squares, this is essentially a plus b times a minus b, which becomes a squared minus b squared. That is the difference of squares identity. If you can recognize that's the pattern of what they're giving you, a is 4 and b is 3i. So if you plug the 4 and the 3i in there, you get 4 squared minus 3i squared. And basically that jumps you down to this stage, and then you can go from there. All right, 4 squared is 16. 3i squared is going to give you negative 9 times negative 1 because the I squared is going to show up again. Okay, number 5, which of these graphs represent the function? So what I see here is in vertex form, okay? So let's review what vertex form is. Vertex form is a times x minus h quantity squared plus k, where h comma k is the vertex. So notice here that the h is after a minus sign. So what that tells us is the negative isn't part of h. So you're going to kind of look at h as what's the opposite of h. So in this example, the h is 3. Not negative 3, but positive 3. Now the k acts different. It doesn't have that negative sign in front of it. So you take exactly the sign that you see. So if you see a minus 2, that's the k. So that gives us our vertex is 3 comma negative 2. The other thing that this form tells us is the a value will tell you if it opens up or down. So the a value is the number in front. If a is greater than 0, it's going to open up. And if a is less than 0, it will open down. And so if we look at our a, we have a negative. That means it's going to open down. So I know two things about this graph. I'm looking for a vertex of 3, negative 2, and it has to open down. So our first option here, 3, negative 2, is right here. That is the vertex. So the vertex checks out, but notice it opens up. That's a problem. So that eliminates this one. If you look right here, this is 3, negative 2, and it opens down. This is our answer. This one has a vertex of negative 3, negative 2. And what they're doing here is they're trying to trip you up on that negative h thing. They want you to look at this negative here and say, oh, h is negative 3, which is incorrect. And then they use this vertex was 3, positive 2, which is making you think that the k has to change sign also, which it does not. Just the h. 6. What is the vertex of this graph? F of x is equal to 2x squared plus 8x plus 3. So this is standard form. So we're hitting all the forms here. Standard form is a times x squared plus bx plus c. Okay, and they want to know what the vertex is. So your vertex is 2 parts, an x and a y. It's a point. It's the point where it goes through. And also, it's the point where the axis of symmetry goes through. So there's a formula for the axis of symmetry, which is the same as the formula to get the x coordinate of your vertex, and that is negative b divided by 2a. To get the y, you have to plug in the x that you just found into the function, and that will give you your output. Okay, so in our example here, we have A, B, and C. A is the 2. B is the 8. Let me use a different color there. And C, I'm going to move my face out of the way so I can see my colors, is 3. Now I don't actually need C to do this formula. I just need A and B. So A, the 2, goes in the denominator, and B goes in that numerator. Okay, so let's fill it out. X equals negative B, which is 8, divided by 2 times A, which is 2, which is equal to negative 8 divided by 4, which is equal to negative 2. There is the X coordinate of your vertex. That's how they got that negative 2. So then how do we get the negative 5, which is the Y coordinate? You have to plug it in. So we need to plug in negative 2 into this function. So I'm replacing X with a negative 2. Be careful to follow the order of operations here. You must do the exponent of squaring negative 2 before we multiply. You cannot multiply first. So that gives us positive 4. Then we multiply. And then we add. Left to right, 8 minus 16 is negative 8 plus 3. And then finally we get negative 5. And there is your Y. Okay, number 7. A fruit grower determines that the bushels F of X of apples produced depends on the pounds X of fertilizer used according to the function. F of X is equal to negative 0.012x squared plus 1.03x plus 2.46. Which graph is an equivalent model for this relationship? So if you look at the different graphs, there's different shapes. And so really you just need to identify which one is a quadratic. And x squared, where 2 is the highest degree, is a quadratic. Quadratic implies it is a U-shaped parabola. So we're not looking at comparing different parabolas here. We are looking at comparing different types of family functions. Like this is a line. The first one here is a line. This is linear. So no. This is a U-shaped graph. This is a quadratic. This is the answer. And it will open down because the A was negative. So this is our answer. This one appears to be exponential. So it flattens out. It goes dramatically down and then flattens out. That is exponential decay. And this one you'll learn is a polynomial function called a cubic function, where the degree is 3. Okay, number 8. The design shows patterns of painted tiles, patterns painted on tiles. The design used depends on the size of the tile. Let n represent the number of the design. Which expression represents the number of blocks in the design? Select all that apply. So you really want to pay attention to how the design number, the 1, the 2, the 3, the 4, is affecting the way that the pattern is. So one thing I noticed was there is a sort of rectangle going along the top. And if you look at that rectangle, you can see that that directly corresponds to the design number for how many blocks there are. There's the design number is 1, there's 1 block. Design number here, there's 2 blocks. Design number 3, there's 3, etc. So you can essentially think of, if the design number is n, then this is n blocks, this piece right here. The other thing I see is there's this square. group together the square and see how that applies. Okay. This is 1. This is a 2 by 2, which gives you 4. This is a 3 by 3, which gives you 9. This is a 4 by 4, which gives you 16. And when you start to attach to the design number, you can see that the design number is basically being squared. So this is essentially n squared. This is n, the design number. This is n squared. So far I have an n squared plus an n. And there's one more portion here. There's a block here, 2 blocks here, 3 blocks here, and no blocks in this one. So I'll say 0 blocks there. Okay, how does that relate to that design number? Well, there's 1 block, 2, 3, they're just diagonal. That appears to be 1 less than the design number. So here the design number is 4 and we have 3. Design number is 3, we have 2. So this is basically n minus 1 here. So I'm going to add on that phrase, n minus 1. And I've got all the portions here. Essentially, I have the whole thing. We can clean it up a little bit, call that n squared plus 2n minus 1, right? We've got like terms right there. And there is one of the answers. Now this is select all that apply, so if we can find another one that is equivalent to that, and you can see this last one is going to be equivalent to that. If I just do a little distribution, I will get the same thing. So make sure to check for those equivalent ones. All right, number 9, which function describes a parabola with the x-intercepts at -3, 0, and 4, 0? This is back to that factored form, or the zeros. A couple of these are in factored form, a couple of these are in standard form. So we can factor them. But we basically want, this is root 1 and a root 2 in either order, it doesn't matter. So that means one of them is going to be x minus -3 or x plus 3, and the other one's going to be x minus 4, the factors, the linear factors. And then there's some value a, we don't know what it is. It can actually be anything for it to have these x-intercepts. So that gives us h of x. H of x has the correct linear factors. It doesn't, the 2 doesn't really change the x-intercept, so it's fine. But we need to select all that apply. So if you look at the other 2, they could factor into something like that, so we need to check. So start with the first one, f of x. There is a GCF of 4 into all 3 terms. So that's the first thing we always want to do is factoring, is take out the GCF. So that's going to be left with x squared minus x minus 48. Oops, sorry, I did not change the 48. You got to divide the 48 by 4 also. That gives 12. Sorry. Then from there, this is a basic diamond problem of 2 numbers that multiply to make -12 and add to make -1. And that would be -4 and +3. And there they are. There's the factors we were looking for, x plus 3 and an x minus 4. So that's why this one is also an answer. If you try and factor g of x, it will not give you those same x plus 3 and x minus 4s. Okay, number 10, 11, 12, and 13 are all basically tied to this function. We want to know if it's concave up or concave down, so opens up or opens down. We want to know what the y-intercept is. We want to know the axis of symmetry, and we want to know the vertex. So we need to get all this stuff from that. So if we look at this standard form. Again, standard form is the ax squared plus bx plus c. You're going to recognize that standard form does not have any parentheses at all. Okay, so concavity is determined by A. It's negative, so it's going to be concave down. Easy. 11, what is the y-intercept? The y-intercept of a standard form is always 0, c. So c is -3, and there's your y-intercept. So 0, -3. Easy. Number 12, the axis of symmetry. This is where we have to do a little bit more work. This is where we use this formula, -b over 2a. Okay, so looking at our B and our A, B was 4, A is -2. We're going to get -4 divided by -4, which is +1. Then for the last part, what is the vertex? The +1 is your first coordinate. You need to find the y-coordinate by plugging it into the original function. So that was, we're going to plug in 1 original function. Plugging in 1, and then we work it out. Make sure to square first. Then multiply, then add and subtract, and we get -1. So the entire vertex is 1, -1. Okay, so 14, 15, 16 are all for this function, which is in vertex form. A times x minus h squared minus or plus k. They may use like a c and a d instead of an h and a k, but it's the same thing. The a works the same. If it's positive, it opens up. So a is 3. It's positive. It's going to open up. And then 15 is what's the vertex? That is just reading the h and the k. Remember, if you see a +3, that means h is a -3. K is a -2. So there's your vertex, -3 and -2. H is the opposite, K stays the same. And what is the axis of symmetry? That is just x equals whatever h is. The axis of symmetry is a vertical line that goes through the x-coordinate of the parabola, the vertex. And so if you know the vertex, you know the axis of symmetry. If you know the axis of symmetry, you know half of the vertex. You just got to find the y part. So, all right, we've got 3 more. Use your knowledge of reference points to write a function for a unique parabola that satisfies a given information. If it is not possible to write a function, state why not. Given exactly 1 x-intercept at 4, 0, and a y-intercept 0, 8. So if they tell us there's exactly 1 x-intercept, then that means you have a parabola that touches its vertex on the x-axis and goes back up. So essentially what they're telling you is this point is the vertex, and it's an x-intercept, but it's a vertex. So you can kind of imagine parabola coming down, it's going to hit it, and then it's going to go back up. So what we could do is we could use the vertex form, which is what these are all in, to help us, because I know that this is h comma k. This is our vertex. And our vertex form is, I'm going to use y instead of f of x. It'll be a little easier here, but it doesn't matter. Y equals sum a times x minus h squared plus k. So what I'm going to do is I'm going to substitute in that h, and I'm going to substitute in the k, and I get y equals sum a, we don't know what a is, times x minus 4 squared plus 0. Now, you don't need to write plus 0. Adding 0 doesn't do anything, so I'm going to erase that. Now, how do I know what a is? Well, I can see it's positive, but positive what? Well, all of these have the same a of 1/2, but I want to show you how you can get that 1/2. What you can do is you can take the x-intercept or the y-intercept they give us, and you're going to substitute 0 for x because it's the x-coordinate, and 8 for y. What just happened? So x is going to be plugged in with 0, and y is going to get plugged in with 8. A is still unknown. This is going to simplify a little bit. 0 minus 4 is negative 4. Negative 4 squared is 16. So 8 is equal to a times 16. You can divide both sides by 16, and then you're going, oh, it's a half. That's where the half can come from. Putting all that information together, there's the a, there's the h, the k is plus 0, but we don't write that. All right, number 18 is like the first one. It's just using I again. Square root of 100 is 10, so you get 10i, so because of the negative. 19, a little harder. We can take the square root of negative 75 and break it up into the square root of negative 1 times the square root of 25 times the square root of 3. The negative 1 becomes I. The 25, the square root of 25, becomes 5. And the square root of 3 stays the square root of 3. If you put the 5 in front, usually that's how we write it. We put the 5, then the I, then the square root of 3. That's how they got that answer. Okay, and then number 20, determine the roots of the function. I can see that all of these options look like they're not going to be something that's factorable because they're not integers or even rational numbers. So we could use completing the square, or we could use the quadratic formula. I'm going to choose to use the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. That is the Pop the Weasel song that kind of goes with it. All right, let's see what my a, b, and c are. My a is 1. My b is negative 1. My c is 7. Okay, so we're going to have negative 1 plus or minus the square root of negative 1 squared minus 4 times a is 1 times c is 7 all over 2 times 1. Okay, so I substituted 1 for here and here. I substituted negative 1 for here and here. And I substituted c with 7 in that one spot. Oh, I guess there's 21 and 22 and 23 still. Okay. I thought I only went to 20. So now we just got to simplify this thing. So this is going to become positive 1 plus or minus. This is positive 1. 4 times 1 times 7 is 28. Okay, so I'm going to get the square root of 1 minus 28, which is negative 27, all divided by 2. Okay, so the square root of negative 27 is the square root of negative 1 times the square root of 9 times the square root of 3. There's your I. The square root of 9 is 3. So that's where this 3i rad 3 comes from. So if we simplify that, the answer is this one. Although it looks like they forgot the minus in the plus or minus. That's unfortunate. Okay. All right, number 21 and 22 and 23 are our last questions, and they're looking at a quadratic in factored form. So factored form is a times x minus r1 times x minus r2. So again, we look at a to determine if it's going to be open up or down. It is positive, so it's open up. What are the x-intercepts? Those are your r1 and your r2, which are positive 5 and negative 2. That's what those numbers come from. And then how do we get the axis of symmetry? So doing this, you have the x-intercepts are at 5 and negative 2. Okay, and it's going to open up, so it's going to hit these two places. Now the vertex is going to be exactly halfway between these. So to get the axis of symmetry, or the vertex, or the axis of symmetry, you need to find the middle between negative 2 and 5. So there's a formula where you take r1 plus r2 divided by 2. So in this case, we can do 5 plus negative 2 divided by 2. It gives us 3 over 2. So 1.5, basically that's 3 over 2. X equals 3 over 2 is right in the middle. And that is how we get our last one. Okay, I hope you found this helpful. I hope you do awesome on your actual mastery test. And see you when I see ya.